So hello everyone and welcome back to a brand new video, and in this video I'll be solving the first three problems from Codechef Starter 71. And as the problems were easy, I will not go that much in depth. I will try to briefly explain the solutions and I will make separate videos for the other problems, right? So let's get into the solutions. But before we move on to the solution, I want to tell you guys about Newton School's coding contest. As you guys know, Newton Schools does this coding contest every month. And this month, the name of the contest is Code Rush X, and the prizes are better than ever before. So you can win prizes up to rupees 10 lakhs. And along with this, you can win placement opportunities in top product companies. So like if you guys want to play this for fun or you guys want to play this for placements, that is totally up to you. The contest will be on 28th of January. It will start around 9 p.m. and the contest will be 3 hours long. So there will be ample amount of time for you guys to brainstorm and solve good quality problems. So if you guys want to benchmark yourself or just win some placements, this is a very good opportunity. I will leave a link to this contest in the comments and in the description, so you guys can go and sign up from there and show, or you can flex how good you are at problem solving. So now let's move on to the solution. So the very first problem was pet store. So this was a very easy problem. So in this, you had just been given an array and you had to answer in yes or no if you can break the array into two equal subsets, right? So in this problem, we were given an array of size n and we had to answer in either yes or no if we could have partitioned the array into two equal subsets, right? So like if we break it into two subsets, A and B, then A should be equal to B. So the problem was really easy. Like if we are breaking the array into two equal subsets, then frequency of every element should be even, right? So to solve this problem, you just have to check if frequency of all the elements is even or not, right? So that was the solution to this problem. And if you guys want to see the code for this, here is the code. So you can just like input the array and keep the frequency of all the elements, and if any element has a odd frequency, then the answer is false, otherwise the answer is true, right? So that was the first problem. Now let's move on to the second one. And the second problem is maximizing LCS. So in this problem, we were given a string of length n where n can be up to 5000. So we were given a string something like s1, s2, s3, s4, so on up to sn. We have two people, Alice and Bob. Both of them have an empty string initially. Alice will go first. She will take some prefix of this array and add it to her own array, right? So let's say she takes s1, s2, s3. So she will remove it from here and add it to her own string, you can say, right? Similarly, Bob will take some suffix. So let's say he takes sn minus 1 and sn. He will take this suffix, he will reverse it and then add it to his own string, right? So now Bob will have sn and sn minus 1. They will keep alternating turns until like the initial string is empty, right? So in the end, you have to answer what is the longest common subsequence that Alice and Bob can generate, like if they perform their turns optimally, right? So that is the problem. So how can we solve this? So you can see that we have s1, s2, s3, s4, so on up to sn. So if you see clearly, your string of Alice will be a prefix of s, right? So the string that Alice has will be nothing but a prefix of s, and the string that Bob gets will be nothing but a reversed suffix of s, right? It will be nothing but a reversed suffix of s. So like if we have a string of size n, we have n ways right? Or we have n minus 1 ways to break this between Alice and Bob, right? Either Alice can take S1 and Bob will take the entire leftover string. Either Alice can take S2 and Bob will take leftover string. Either Alice can take up to S3 and Bob will take leftover string, right? So initially there are n minus 1 ways to like partition strings between Alice and Bob, and we have to find the partition which will give us the maximum longest common subsequence. So like this problem is just a variation of the standard longest common subsequence. So like we can create two separate strings here. Let's say your string s is equal to s1, s2, s3, so on up to sn, and you will create a new string s dash which will just be the reverse of this string, right? So let's create a new string s dash which is nothing but sn, sn minus 1, sn minus 2, so on up to s1. And as we saw in this diagram, right, as we saw in this diagram, let me redraw it again. So we have s1, s2, s3, s4, so on up to sn. So we have n minus 1 ways. The first way is that Alice takes the string of character 1 and Bob will take the leftover string. Bob will take the leftover string, that is n minus 1 characters. So like if we try to visualize this here, Alice will take the first character and Bob will take the leftover characters up to n minus 1. So you can say that your answer will be what? It will be just longest common subsequence of 1 and n minus 1. Similarly, if your Alice takes 2, right, Alice will take a string of length 2, Bob will take the leftover string of length n minus 2. If we see it here, it will take 2 and Bob will take the leftover string that is made up of n minus 2. So you can say then your answer is just LCS of 2 and n minus 2. Similarly, you can say your answer is also equal to LCS of 3 and n minus 3, and so on. Answer is equal to LCS of n minus 1 and 1. So like you can easily calculate all these values in O of n square time, and your answer will be the maximum value among all of these, right? So you can say your answer is just maximum value among LCS of 1 n minus 1, LCS of 2 n minus 2, so on up to LCS of n minus 1 and 1, where you create two strings s, this is your like the real string that you have, and you create a new string s dash which will be your reverse string, right? So you do the longest common subsequence algorithm on these two strings, and your answer will be the maximum among these values, and you can easily find this in O of n square time. And as your n square here, as your n here is up to 5000, so like you can easily perform a O of n square algorithm here, right? So if you guys want to see the code for this, here is the code. So I will just take in my string n and s, then I will create a new string t, or you can say s dash, and I will reverse it. Then I will pass it to my LCS algorithm. So like it will compute the LCS 2D array, and then I will go over all the elements li n minus I will iterate over all the elements l1 n minus 1, l2 n minus 2. So I will iterate over all those values, and my answer will be the maximum among all those values, right? So I will find my answer and I will return my answer. So this was the following loop, right? So it will return me this value. So that was the second problem. This was just a like very good variation of the standard longest common subsequence problem, right? So these were the first two problems. Now let's move on to the last one. So the last problem is flip the prefix. And in this problem we have been given a binary string. We have been given a binary string of length n, where n can be up to 10⁵, and we have also been given an integer k, where k is less than equal to n. And we have been given a binary string, so s1, s2, s3, so on up to sn, where your si belongs to 0 or 1, right? That is, your string s is a binary string. Now you have been given an operation. In one operation you can choose some prefix of this array or of this string and flip it. And you have been asked to find the minimum number of operations that are required to get a consecutive set of k1s, right? Find the minimum number of operations that are required to get k consecutive ones, or you can say a substring of k1s, right? So that is the problem. Now how can we do this? So like we can do this using a brute force manner. So we can iterate over all substrings or all subarrays of length k, and like find the number of operations that are required to solve that substring, right? So our approach will be iterate over all subarrays of length k and find the answer, or you can say find the minimum answer among all these subarrays, or you can say substrings. But now the problem here is, right, to iterate over, like in total there will be n minus k such subarrays, and like if we iterate over all the subarrays, it will take us n minus k into k time, right? N minus k into k time. So this can like go up to O of n square, and as in this case my n is 10⁵, so like this will TLE. So I have to like iterate over all the subarrays of length k, but I have to do it in a smart manner. So if I want to iterate over all the subarrays of length k in a smart manner, I will use two pointers. So I will have s1, s2, s3, s4, so on up to sn. So I will keep a sliding window or two pointers. So initially I will have a sliding window over like this subarray of length k. I will find the answer for this. Let's say answer for this is answer 1. Then I will shift my window one index to the right? So my window will then move from s2 to s of k plus 1. Then I will find the answer for this. Let's say answer for this is answer 2. Then I will again shift the window, and so on I will keep shifting until I reach the last index. And let's say answer for this is something answer of whatever this is. I think this will be answer of n minus k, right? So my final answer will be minimum of answer 1, answer 2, so on up to answer of n minus k. So like that will be the approach. But now the main point is, how do I find the answer? I have to find this answer in constant time, right? Because I am shifting this window k times. So I have to find this answer. So right, this complexity is to shift the window. Now I have to find the answer. In either constant time or either in log time, right? This will be n minus k. So you can say this is taking me O of n time to shift the window, just right? So I have to find the answer in either constant or log time, otherwise my complexity will again go to O of n square. So to stop this from going to O of n square, I have to find my answer in constant or log time. So how can I find my answer in log time? So like let's see an example of a subarray and try to count the number of operations required for that. So let's take some example. So let's say subarray is something like 0 0 1 1 0 0 1 0 0 1 0, right? Let's say your substring is something like this. So like count the number of operations that are required to convert this to a complete substring of ones. So obviously we want to convert this 0 to 1, so we'll apply operation here. So we apply the operation here and this becomes 1 0 1 1 0 1 1 0 0 1 1 1, right? So now this is a 1, so we can ignore this. Then we will apply the operation here. So this becomes 1 1 0 0 1 0 0 1 1 0 0 0. Now this is also a 1, so we can ignore this. Now let's apply the operation here. So this becomes 1 1 1 1 0 1 1 0 0 1 1 1. So I hope you are able to see the pattern here, right? So you can like see this entire substring as segments. This is the first segment, this is the second segment, this is the third segment, fourth, fifth, sixth and seventh. And in every operation you will convert one segment to ones. So first of all we take the last segment, apply an operation on this will be converted to a 1. Then we take the second segment here, we convert this to ones. Then we take the third segment, right? Then we convert this to a 1. So every segment will require one operation. So we have 7 segments. This is segment 1, right? Let's go segment 1, segment 2, so on up to we have 7 how many segments? 1 2 3 4 4 1 2 3 4 5 6 7. So we have 7 segments here, right? So this will require 7 operations, right? So like in every substring you can just count the number of segments, and that will be the number of operations that are required to convert this substring to whole ones. But there is an exception to this. The exception is something like this. We have 0 0 1 1 0 0 1 1, let's say, right? If you see here, the last segment is already made up of ones, right? This is segment 4, this is segment 1, this is segment 2, this is segment 3. Here the last segment is already made up of ones, so we don't have to apply an operation here. So we just need to apply an operation on segment 3, then on segment 2, and then on segment 1. We don't need to apply an operation on segment 4 because it already has ones. So this is kind of an exception. In this case your number of operations will be segment minus 1. So like these are the two cases that we need to take care of. So let me write it down as well. So to find the answer for a fixed length substring of length k, just count the number of segments. Count the number of segments. And if your last segment is made up of zeros, then your answer is equal to number of segments, like we saw in this case. Otherwise, if your last segment is made up of ones, then like we get a takeoff of one operation, right? So if last segment is made up of ones, then your answer is number of segments minus 1, right? So that is how we compute the answer. So now we know how we want to solve the problem. So let's move on to the approach. So we have S1, S2, S3, S4, so on up to Sk, so on up to Sn, right? So we have initially the sliding window over here. So you can count the number of segments in this, right? Count the number of segments in this, and like using the segments, find the answer 1. Then shift your like a window to S2 to Sk plus 1. And as you are shifting from S1 to S2 and Sk to Sk plus 1, only the segments will change here, right? Only segment at S1, S2, and only segment at Sk and Sk plus 1 change. So like just keep care of these two indexes and like keep track of number of segments that will change here. So when you move from S1 to S2, see if number of segments are getting decreased, and when you move from SK to SK+1, check if your number of segments are getting increased. So initially change the number of segments here. You can do this in O of 1, right, because you only need to take care of 2 indexes. So like count the number of segments in O of 1, and using this find answer 2. So now you can see that you can in constant time find the answer for every new segment, right? So you will need O of n minus k time. This is to move your sliding window, and you will require constant time to find the answer for every segment, right? So in total you will take O of n time. This will be your final complexity. So that will be the entire solution to this problem. And if you guys want to see the code for this, here is the code. Yeah, so you will take your n and k, then you will take your string. So initially the number of segments will be 1 and your answer will be n, right? That is the default answer. So this is your 2 pointer, L is equal to 0 and I is equal to k minus 1. So initially count the number of segments in the initial segment. So count the number of segments, and if your segments are ending with a 0, then your answer is just minimum of answer and segments. But if your segments are ending in a 1, in that case you don't have to apply one operation. So in that case your answer is equal to minimum of answer and segments minus 1. Then keep moving a sliding window. Keep moving your sliding window until you hit the last index. Increment your L pointer and check if your number of segments are getting decreased. If they are, decrement them. Similarly, update your right pointer and check if your number of segments are getting increased. If they are, increment them. Then again check your last segment and find your answer accordingly. And in the end you can just print out the answer. So that was the third problem, and that was it for the first 3 problems. If you guys have any doubts, feel free to ask in the comments or join my Discord server. I'll be more than happy to answer your doubts there, and I will see you guys in the next one. Bye bye.